Okay, for this third video now, we're going to consider something called a series. And this is going to be introducing just some vocabulary. We're not going to do anything with it. Instead, we're going to start working with series starting next week. So we're going to think of a series as being a special kind of sequence, but it's also something you build out of a sequence. So there's a potential for it to be a little bit confusing, and that's what this video is hopefully going to clarify. Okay, so we're going to say that we start with a sequence, and let's call that sequence AN. And then out of that, I want to build a new object, and I'm going to call this new object a series. So let's start here with an example. We have a sequence where the terms are AN is 1 over 2 to the n, and we're starting at n equals 0. Right, so that's a sequence. Right, it's the sequence that we started this with. It's the sequence whose terms are 1, 1/2, 1/4, 1/8, so on and so forth. Now, we're going to define the series associated to this to be this expression. We're going to say it's the expression, we use the sigma here to mean a sum, so that's the sum from n equals 0 to infinity of an, where we take a0 plus a1 plus a2, etc. So in our example, we get 1 plus 1/2 plus 1/4 plus 1/8 plus etc. And so at some level, we can think of this series as just being this expression here, right? We can think of this as an expression. But what we really want to do is we want to think of it as a number. And so to make sense out of it as a number, we need to think of this as a limiting process. Right? That's secretly a limit. Okay, so what we're going to do to make sense out of it as a limit is to consider what we call the sequence of partial sums. And it's defined to be the sum of the first bunch of terms of our sequence. Right, the sum of the first bunch of terms of our original sequence. Right, so here, for instance, S0 is going to be the sum from k equals 0 to 0 of a0, right, so that's just 1. S1 is going to be the sum from k equals 0 to 1 of our AKs. So that's going to be a0 plus a1. So that's going to be 1 plus 1/2. Right, and then S2 is going to be 1 plus 1/2 plus 1/4. And S3 is going to be 1 plus 1/2 plus 1/4 plus 1/8, and so on and so forth. Right, so that's the idea of the sequence of partial sums that we're considering. And I'm just going to emphasize here that this is confusing jargon the first time you see it. After a while, it'll become second nature and you'll be fine. But right now, it's confusing jargon, I think. So what we're going to do is we're going to start with a sequence of terms. Right? This is a sequence of terms. That's the first bit of jargon. The series is this infinite sum, and the sequence of partial sums is what we get by adding up some number of terms of, right? It's basically stopping before we reach infinity on our series. So that's what this jargon is about series and the partial sum on the series and this kind of thing. And what we're interested in is one that sum looks like something finite. So if the sequence of partial sums has a limit, and that limit is a finite number, we then say that that is the limit of the series, and the series converges. Now, if the sequence has an infinite limit, or if it doesn't have a limit at all, we're going to say it diverges. And next week we'll see methods for determining when a series converges or diverges. But let's look at a couple of examples that we can understand right away. Okay, so let's take 1 plus a half plus a quarter, etc. Well, let's just think about what happens. Right? There's a little story that goes with this. Imagine that you have a frog, and here's my number line. I'm going to put 0, and let's put 1 here, and let's put 2 here. And we have a little frog. Okay, I'll make a green dot here because he's a frog. Okay, let's make him dark green. Okay, so my frog starts at 0, and he jumps, and he's going to make a jump of length 1. He's going to go whoop. He's going to jump there. And then he's gotten a little bit tired. He's going to make another jump. He's going to go whoop, and he's going to land right there at, right, that's going to be 1. And then we're going to add plus 1/2, and he's there. He made a jump that was half the length of the previous jump. And now he's going to jump again, except he's even more tired, and he's going to make it only half of the way, right? So he's going to make a jump here of length a quarter. So that's like that. He's going to end up there. And then the next jump, he's going to make it half. He's going to make it to 1/8. And he's going to keep going like that, where his jumps are getting smaller and smaller because he's getting more and more tired. Well, from the picture, it's clear that the limit is 2, right? That's clear from the picture, from the diagram. Right, so that's an example where we understand what's going on by making an appeal to a diagram and some intuitive understanding of the situation. Now, the next thing we can look at is, let's take a look at a different series. Let's look at the series, let's take the sum from n equals 1 to infinity of n squared. Right, so that's going to be 1, that's 1 squared, and then we're going to get 2 squared plus 3 squared. Right, and we see we keep adding bigger and bigger stuff. There's no way this can have a limit, right? The sum, this wants to be infinite. Right, that's no good. No good. So this is going to be an example of something that diverges. But let me give you another example of something that diverges. Let's consider 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1, etc. Right, I'm going to write that as the series from n equals 0 to infinity of minus 1 to the power n. Right, that's a perfectly valid series to write down. And the question is, does it converge or diverge? Well, let's take a look. Let's give ourselves a new page here. And so we're going to look at this series. Right, so that's going to be 1 minus 1 plus 1 minus 1 plus 1, etc. Well, if I take an even number of terms, so for instance, 1 minus 1, or 1 minus 1 plus 1 minus 1, 1 minus 1 plus 1 minus 1 plus 1 minus 1, all of those are 0. If I take an odd number of terms, I'm going to get 1, 1 minus 1 plus 1, 1 minus 1 plus 1 minus 1 plus 1. Well, those are going to be equal to 1. So then, right, the sequence of partial sums alternates. Between plus 1 and minus 1. Right, so that's that is what it is. And it's kind of good, right? We're going to say that this means the series diverges. And I said I think it's kind of good because, watch, I'm now going to give you one of my favorite garbage proofs that 0 equals 1. Right, so I'm going to say that 0, that's equal to, well, actually, let's do an intermediate step. Let's write this as 0 is equal to 0 plus 0 plus 0 plus 0, etc. Well, 0, I can write it as plus 1 minus 1. And now I'm going to rewrite that as 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1, etc. Right? So far, I've just done some algebra. And now I'm going to regroup it. I regrouped it. And now I'm going to collapse the groups. So, 0 equals 1. Nice proof, isn't it? Let me know what you think. We can discuss it in the discussion forum or talk about it in class if you're so inclined. But pretty happy 0 equals 1.